the lesson on the structural set of plans. And I'm going to be referring to these questions for the structural set, but we're going to do a quick walkthrough first, and then we'll start to hunt down the answers to these questions. This is 2 pages, a total of 16 questions. And this will just pertain to the structural set within the Ross Technology building. So let's go ahead and dive into the set. First of all, this set does not include a page that has a legend, I don't believe, but I'm going to go ahead and look through every page here and we'll see if we can find it. The first page that we looked at here is the structural foundation. Then we have some framing plans. So this is showing the first floor framing of the structural framing. This is showing the second floor structural framing. And then we have the roof framing. So there's 3 levels of framing that we have if we include the roof deck. Then it goes on to a lot of bracing details and structural connections with beams, and these are close-ups of how the beams are being connected, or I should say rather how the floor trusses are being connected to the beams. Some more connection details and bracing details, and then we've got some typical details for pier bases or footing, or pads are called. And then we've got a typical foundation wall detail. So we're going to be taking a look at those. More details. There's a lot of structural details. We do have a section here that is, I think this has got some of the soil bearing capacity that was done on the civil that's included in the set to help determine what size pads and framing members and things like that need to be provided for holding up the structure, because obviously the soil bearing has a lot to do with that. So we're going to take a look at that. So that's going to be an important section to look at. And lastly, we have one more page of details. So you can see as we went through that, none of those had a legend or abbreviations page. So we're going to have to do some sleuthing and kind of figuring some stuff out. So that's the full set. And we're going to start with looking at a little bit closer at the foundation. So the foundation is showing what's going on from the very lowest points of the building and what's being placed as are the footing, and then piers on top of the footing that are supporting the superstructure of the rest of the building. So the little black rectangles that we're seeing all through here are columns, and then the hidden lines that are around those columns are the pads that are spreading the load from the weight of that column to a wider area based on the soil bearing capacity. There's a lot going on this page, a lot of callouts, a lot of leaders and things. So it looks a mess, but we can make some sense out of it. And I do have a 3D model of this so that we can take a look at it and get a sense of where we are. So this is what we're looking at is that foundation. That foundation is you've got a full foundation basement area. In other words, underneath the foundation are all those pads that we were seeing that are holding up the weight that the columns are holding up. And if we bring this up a little bit further, you can see there's the first floor. So that's holding up the first floor. We've got our first floor layout. I don't have the structural framing in here yet, but it just gives you an idea of how it's all holding up all that structure. And the heights of these columns that we see here on the edge, on the outside, and where they are located all have to do with the column grid and the datum that's being used for measuring the elevations of all these things, which is going to be the slab level in the basement. And so this is going to have a lot of height information and depth information that's in the foundation, and that's where all the callouts are coming from. That's why there are so many callouts in this plan. So let's take a look at this for instance, in this close-up of these columns that are located. First of all, they're located and they're centered on a column grid. So I can identify this column right here as being column 7A. That's the only column that can be column 7A because it's located right there at the intersections of those two column lines. So it's a really great way to be able to label and identify a column. The column is being called out as P1 or pier. Piers or columns can be interchangeable. Piers usually means that it's made of concrete. A column might be steel, but they're more or less interchangeable. So P1 is a kind of column or structural vertical member, and the plus 10 feet 8 inches is an indication of how high it's going above a certain level. And then F8 is the footing. So there's the footing right there that we can see. And it's going below whatever that level is, down -1 foot. So we need to find out what is the level that's being used to be our datum, or 0 feet 0 inches, that we can calculate the height of the column from here and the depth of that footing from that same spot. And right in the middle of the floor plan, in a box, anytime you see a box, any call out with a box around it, you want to read it. It usually means that it's important. And this is telling us what size the slab is, 4 inches on grade, with fiber reinforced finished floor elevation. And there is our magic number right there. It says plus 0 feet 0 inches. So that's the datum that we're using. In other words, we're calling the slab 0. The slab in reality is 12.20 feet above sea level. That's why it says equals 12.20, because we do need to relate this in the site plans to where it actually is in the real world. So the 12.20 feet is the actual sea level height from the slab to where the sea level is. So this is pretty low. We're pretty low altitude, as low as we can get here in Maine. And if you have been on our campus, you are familiar with the location. It's right next to the marina. It's not far. And so it would make sense that the slab, which is the lowest level of that building, is only about 12 feet above sea level. So, but that's the magic number that tells us how to interpret all these numbers. So this plus 12'3" means that the pier is at a height of 12'3" above the slab. This footing is at a height of -1 foot, or depth, I should say, of -1 foot below the slab. And that's how you would interpret each one of these. So we can take, for instance, this outside, this is called an areaway, and it's creating the space that we need to have the intake for the mechanical system that's providing fresh air to the rest of the building. And we have a TOC and a BOC. TOC stands for top of concrete, and BOC stands for bottom of concrete. So if we have a top of concrete, meaning the top of this areaway structure is at 12 feet 9 inches, and the bottom of that same areaway structure is at 0, we can determine that the height of this wall that's surrounding this areaway and creating this space on the inside for us to intake that fresh air, the height of those walls are 12 feet 9 inches. And that's how you read this. So TOC and BOC stand for top of concrete and bottom of concrete. And we have the same callouts over here. So it's exactly the same size. Not the same depth and length, but the same height. If we look at the other side of the building, these are the areaways that are being used to create space around these windows that happen to be below grade when they were designed. So we have a top of concrete of 12'9" and a bottom of concrete of 5'6". So what we have to do is subtract 5'6" from 12'9" to get the height of that actual wall. So if we do that, we get 7 feet 3 inches is the height of that wall. So that's how you read those TOC and BOC callouts. So it shows you the depths and height relative to the slab all throughout here. Okay. And so let's take a look at where we can find out what P P1 and F8 stand for, because these are calling out different types of piers and footing. And at the upper right corner of this plan, we have a footing schedule and a pier schedule. And we now know that schedules are just lists, basically, of all the different examples or different iterations of something. So we have 3 different piers that are being used. Technically, we have 4, because one of them is a steel pier being used in the inside. So these are columns that are a standard American Steel Material Standard A325, which is a call out for a particular size column. So that's why these just say NP. But each pier, which is a concrete pier with rebar in it, is called out here with their sizes and their type. So you can see what size it is. It's a 12 by 18. It has 4 number 5 rebar. And number 4 at 12 inches on center. And so it's you can see where the rebar is located around the corners, and then the ties are number 4 rebar at 12 inches on center, meaning that if we were looking at the column from the side view, every 12 inches up the column, you'd have a tie that's tying those 4 rebar that are going vertically through the column. It's tying them at 1 foot increments for the entire column height. So we have layers, if you will, of ties that are tying the rebar in place. And column P2 is a different size, and P3 is another size. So we have those 3 different types that we're going to see throughout this set, or throughout the foundation plan. When we look at our column bubbles, always look to see if there's any column bubbles skipped, or things that maybe don't make any sense. Now, I will point out we have 2 column bubble 7s, but the reason for that is we actually have 2 buildings. So this building here is the column bubble 7 for the Hague building, and then we can see it's 6, and it's would continue if we saw the rest of Hague building. And then they're using column A to locate where columns exist in the Hague building. So we're going to ignore these column bubbles here and pay attention to the ones. You can tell that they're a little bit bolder lined, and they have actual dimensions that are applied to them to indicate where those columns need to be located based off of the existing structure. We're 1 foot 4 inches from the existing structure to the first column line. And then from that column line, every other column line is being placed. And you'll notice that all the dimensions are going from a column line somehow to a critical dimension. So this is showing where the edge of the footing is going to be when, or the edge of the foundation wall when it's done, is 10.5 inches to the edge of the foundation wall. So it shows where everything is going to be relative to where that column line is. So column lines become really important and become kind of those pieces that we use to place everything else in a structural drawing. So let's see, what else can we point out on here? So these are all of our typical. Anytime you see typical, that's a good call out to go and take a look at, because it's going to show you typical construction through this window and areaway. So what's happening right here is the same thing that's happening obviously through each one of these windows. So they show it once and say typical. There's another typical. This is showing you what's the typical construction going to be in the actual wall system. And then we have more specific callouts that are happening. If they don't say typical, it means they maybe are atypical or are being called out or shown because of a uniqueness to them. When you see double callouts like this, it means that there's something happening here that is being shown on 2 different sheets. So we can see A3 stands for the architectural view of the callout, and C2 stands for the so you have TA 30.1, it's the architectural callout, TA, and TS is the structural callout. So we have an architectural version of the same wall section and a structural version of the same wall section. The architectural version is going to have general finishes called out, and will indicate to reference the structural callouts for any structural member information, and the structural callout will have all of the structural information in it, like bracing, steel and structure. So that's why there are two callouts there. It's to reference that we have it being shown in two different places in the entire set. So pay attention to whether or not it says TS or TA to know where to go within this set. The TS are the ones that are going to be part of the structural set. All right, next page is our framing. And in framing, you have the column grids are showing up again. And what this is basically showing you is the size of the framing members that are being used to support the structure. So this is the way to read a framing plan. First of all, the columns, what are they supporting? They're supporting the ends of these beams right here. So this is a major beam, W18 by 35, W30 by 90, W18 by 35. Those are the size of a W beam is a certain shape. It actually looks like an I, but it is actually called a W beam. And the size call out is the depth and then the weight per linear foot of the beam. So these are heavy. So this is 90 pounds per linear foot, and it's got a depth of 30 inches. So it's a pretty good size beam. And it's holding up a lot of weight if you look at how far across it's going, okay? The W18 means it's a depth of 18, and it weighs 35 pounds per linear foot. These members, they're called K-series trusses. And so 22 is the depth of the floor truss, and K6 is just the size, indicates the size of the steel that's being used to create the framing. So we have the way the framing's going is the hallway has its own framing because all of the framing members and the structural beams are going down the hallways on either side. We have spans from the outside exterior wall to that inside beam. And then this is the longest span right here. So you can see that these are 22s by 10, 22 K10. So K10 is going to be a heavier duty floor truss, and but the depth is still the same. These are only 14 K1s. So 14 means it's a depth of 14 inches, and a K1 has got just a lighter gauge steel being used to create the floor truss. And then underneath the classrooms on the opposite side of the hallway here, we have pretty much the same, spacing and call outs to support that framing. And if we look at the second floor framing, you're going to see some similarities, but some of the trusses may be a little bit different size. Let's see. Actually, they didn't seem to change any size, so they kept the same exact trusses. We do have 22 K7s here. Let's just check to see if we had the same size on the first floor. And I suspect, yep, we do have those 22 K7s. And what I would like to look at is see if those are where the condenser unit is going to go in the roof system. So the last page that we have here is between column lines 6 and 7. Oh no, actually it's column lines 4 and 5, so never mind. I took a guess and I was wrong. So between column lines 4 and 5 and column lines A, B, and E, so let's see if we can locate that. Here's 4 and 5, and we have A, B, and E. So right here in this area is where that new condenser is going to go to support the condenser weight in the roof. So this is the alternate number 4 roof framing modification due to condenser installation. And we can see that instead of having this basic layout for supporting just the roof structure alone, we have to beef up that section because it's going to be holding the weight of that condenser. So this is the replacement of that framing because we did choose to go with this alternate. So that's what actually happened with the building. And if we zoom in on these, we have kind of a similar layout of where the framing goes. And the size of the K-series trusses are varying based on their spans and their spacing. And then when we get into the details that show bracing and structural brace details, these are can be somewhat difficult to read if you don't pay attention to where you are in the set. So what this is doing is illustrating bracing that's going in the wall system between two column lines and between 1, 2, 3 levels. So starting in the foundation, in column line E, we have a cross bracing, diagonal bracing that's going from column line E to I. And then from I to E, and then from E to I again. So where are column lines E and I is what we have to do. This is column line 5, and we're going to find column line 5 and then locate where E and I would be. So let's go back to our framing detail or framing plan. Here's column line 5 right here. And we're looking at E through I. So there's I, there's E. And that's telling us that our bracing, I'm just going to rotate this whole plan if I can. Let's see if I can rotate the whole plan. It would be nice if I could do that. Edit, rotate. Let me see here. I'm kind of new to this PDF reading system here, so I'm trying to find out where I can make changes. I bet you it's this one here. Page fit, actual size. Rotate view, there we go. So I want to rotate the view clockwise. And the reason I'm doing this, folks, is for you to be able to visualize what's going on. So remember that column line E was on the right and column line I was on the left. And starting from the foundation level, we had cross bracing that was going from E to I, so down column line 5. So here's column line 5 right here. And we can actually see the hidden line that's showing up for the bracing. So that column from the foundation, at the base of the foundation, because we're on first floor framing, I think, right now. So it's at the bottom of the bracing, diagonal bracing, in the foundation on this side, and it's going up to the floor, this floor level on this side. And then if we go to the second floor, oh, that was the second floor. Then there's that bracing again, and we can see it, and it's going in the opposite direction. It's going in the opposite direction diagonally. So if I were to do a elevation of that, looking at it in this direction from the same direction as the detail, that's what that detail is explained right there. That's what we would see, is that cross bracing moving up and diagonally supporting those columns and the floor framing to prevent them from buckling. So that's how you read the bracing details. You have to find the column line 3, and then you have to put the bubbles in the correct direction. So this is, if the bubble A is on the right, you want to think about rotating the plan so that the bubble is on the same side as this bracing detail, and then you can kind of visualize what's going on with that once you rotate those plans either in your mind or in the set. And the last thing that we're going to take a look at is how exactly are we providing support in the foundation system, in the pads and things like that. So this is interior column footing detail. So those interior columns are the ones that were the steel columns that we saw in the middle that were called out as NP. This is just showing, where the rebar is going to be located, that there's going to be that reinforcement in both directions. So it's going to be a grid pattern of reinforcement in the pad. How far down the footing needs to be in order to clear the slab. It's showing you that this area here needs to be clear 8 inches to provide the space for the column pad and the connection to the base of the column to the pad. And so this has given us clear instructions on where all that needs to be. The next detail here is a typical pier and footing detail. So the piers, remember, are the ones that have the rebar in them. This is showing a pier that's not the, it's not, don't, you notice that there's no height here that's being shown from the top of the pier to the pad. The reason for that is that height information, remember, is in the plan view that shows all of those height callouts based off of 0 feet, 0 inches of the slab elevation. So that's why we're not seeing any height information for this part of the pier. But we are getting some spacing for rebar and knowing where our column base is, and then our actual column that's going to be supporting the steel column is going to be supported by that pier. This pier is being supported by this footing. And this one is a foundation, a retaining wall. So retaining wall is where we saw those details that showed where the intake is for the mechanical units. This is a retaining wall, similar setup for the window area ways. So that's showing us, you know, how is that going to be built? Where is the reinforcement going? And the call outs for that. And then lastly, this is showing us what our foundation wall is looking like. And our foundation wall is kind of flimsy. The reason it's flimsy is because it's not really the structural, the wall itself is not structural. It's really not holding up a whole lot of weight because the beams and the piers that are showing in the column grid are really doing all of the heavy lifting, which is why they have such huge pads underneath them. So this is just to provide an enclosed space for that basement and seal it and kind of create that foundation. Okay, so that kind of gives you the long and the short of what's going on in the drawing. And let's just take a closer look at this. That just as I suspected, your soil bearing information, we can see that the bearing capacity of our soil is 2,000 PSF. So that 2,000 PSF helped determine the size of these pads and the structural weight that they could bear. And then this tells you what's the PSI required for the columns and for the slabs that are being cast in place, concrete, and all kinds of other requirements and call-outs to meet the code requirements for safety and structure. And then the types of concrete reinforcing that need to be built into and designed into the structural and framing members. So this is sort of like a code review that proves that they are meeting the requirements of structural framing per this type of building. So this is pretty important to make sure that all of the details over here are meeting those requirements. So there's our little tour. So now we're going to begin the answering the questions. So I will start on page 1. And we have, what is the finished floor and elevation in the foundation plan? We found that right away. This is our finished floor elevation right here is 12.20 feet, but it's being used as datum 0 feet 0 inches throughout the foundation plan. So I went at the end here, I'll give you an indication of how I've written out the answers. All right, so the next question I have is, what does P1, 11 feet plus 11 feet minus 1 inch stand for? So we know that P1 stands for a pier type. So what kind of pier is it? It is a 12 by 18. So I'm going to put P1 equals a 12 inch by 18 inch pier. And what does the plus 11 foot 1 inch stand for? It's plus 11 feet 1 inch from top of slab. And that is our pier height. Okay. What does F8 negative 1 foot stand for? So we know F8, F stands for footing, P stands for pier. So if we go to our plans, let's look for F8. F8 is an 8 foot by 8 foot by 1 foot 6 footing. And we're going to write here a depth of 1 foot 0 inches, negative 1 foot 0 inches from top of slab, because top of slab, remember, is our 0 feet, 0 inch datum. What size is the F9 footing? Well, we can stay right here. The size of F9 footing is 9 feet by 9 feet by 1 foot 9. What size footing is below the pier at column E8? So we have to go find column E8. So there's column line 8. Let's look for E. There's E. So there's the column E8. So what size, what did it say, what size footing is below that column? So that's a P1 column and it's size F7. So an F7 footing is below that column. Why are column lines C and F skipped on the right side of the building on the foundation plan? So let's see, we have A, B, then it jumps to D, E, and then it jumps to G, H, I. So where are column lines C and F? They should be either on this side of the building or on that side of the building. And when we zoom in on this side, there they are, C and F. Why are they over here on this side? And if we look at what they are locating for columns, they're locating the columns that are creating the structure around the elevator shaft. So this is the elevator shaft, and it's a cavity basically that's going from one floor to the other. And so we need to have columns there that are supporting the floor framing that are going around that cavity. So C and F are columns supporting the floor system around the elevator shaft. Okay, so that's why they're located at the left-hand side instead of the right. TOC stands for top of concrete and BOC stands for bottom of concrete. What is the stem wall height of the window areaways on the north side of the building? So this is our north side of the building, remember. We found that out when we were looking at another set. Project North is down in this set, so that means this side of the building here is the north side of the building. The window areaways are where these windows are located. There's an areaway that's been designed around it in order to allow use that as a retaining wall to keep the grade that's above these windows from caving in on the windows and actually letting light in. So these areaway windows have a top of concrete at plus 12 foot 9 and a bottom of concrete at plus 5 foot 6. So that means the height is 12 foot 9 minus 5 foot 6. So that is 7 feet 3 inches would be our height. Okay. And we're on to question 8. What size floor joists are being used between column lines B and E? What size floor joists are being used between column lines B and E? So we have to find those two column lines, and then we're going to figure out, you know, where those floor joists are, or what floor joists are being called out there. Whoops. All right. So let's go to floor joists. And did it say what floor? Well, we'll go to the first floor to begin with, and we'll look at what because they were identical on the first and second floor. I think I checked that. So there's column lines B and E right there. So between those two column lines, we're not counting these two 22K10s because those are going between column lines A and D. So the two that are going between column lines are the floor joists, I should say, they're going between column lines E and B are just the ones in the hallway here. We're not also counting this one because those are going between E and D, not E and B. So we're going to look at just those two column lines, and we can see that all of them are 14K1s. And then they're the same on the second floor. So 14K1s. List the column lines that are supporting the first floor joists. All right, so these are the column lines that are supporting these joists. We have a column here that are supporting the ends of all these joists that are in these classrooms and in this classroom. We have a column line here, B, that's supporting the ends of the joists in all of these two classrooms here. We have column line D that's supporting the ends of the joists in this one classroom here. And then we have this entire column line, E, and then we have this entire column line over here, I. So if we were going to list them, the ones that are supporting the floor joists are the ones that are at the ends of the floor joist, on the ends of either one of the spans, and they would include column lines A, B, D, E, and I. How many W18 by 35 are being used to support the floor framing? So let's look to see how many we have. We have W18 by 35, 1, 2, 3, 4, 5, 6, 7, 8 are being used to support that floor framing. I see 8. And I'm just going to, and this is first floor framing, so it did indicate first floor framing. So there's 8 W18 by 35s. What is column 4B supporting? So let's look for column 4B. We go up here and look for 4 and look for B. And the hierarchy of the way structure works is the column supports the beam, and then the beams support the floor joist. So what is column 4B supporting? It's supporting the ends of these two beams. So it's supporting 2 W18 by 35s. And then it's also supporting the weight that those beams are supporting, but it's directly supporting W18 by 35. What is the distance from center to center for the floor joist in the column bay between 3 and 4? So let's look at column bay 3 and 4. There's column bay 3 and 4, and it says to use 6 equal spaces for the floor joist. So if we want to figure that out, we have to take our 21 feet, 3.5 inches, and convert that to decimal feet. So let's use a calculator here. Have a calculator, I hope. Oh, let's use it this way. Here's our calculator. And I'm going to take 3.5 inches and divide it by 12 and get 0.292. So 21.292 feet divided by, I just added 21 to that, divided by 6 means that the spacing between those floor joists is 3.549 feet. So we have a spacing of 3.549 feet between those floor joists based off of that call out. 6 equal spaces. We have 1, 2, 3, 4, 5, 6 equal spaces. So you notice I'm not counting the actual floor joists, I'm counting the spaces between them. We end up having 1, 2, 3, 4, 5 floor joists because we're not including the one here. And that gives us our spacing. Alternate framing is required for what reason between columns 4 and 5 and rows A, B, and E? And we already know that one. Let's go to the roof framing plan, and we will look at again the alternate for the roof framing plan, alternate 4. There it is. And that is supporting the condenser. So we know that it's supporting the condenser. For alternate 4. There we go. Wall and column footings were designed for an assumed soil bearing of, hey, that came in handy, didn't it? We need to reference again what those surveying soil bearing tests provided for information. So we want to zoom in on this. There's our 2000 PSF, pounds per square foot. What is the depth of the footing for the 8-inch foundation wall and what size are the dowels? So we want to look for that typical 8-inch foundation wall. There it is. And it is asking for the depth of the footing is 1 foot. And the dowels are number 2, 2 number 4 dowels. Number 4 dowels at 18 inches on center, extend 24 bar diameter into wall and footing. So this is the, what do you call it? Kind of like it's acting like an anchor bolt between the foundation wall and the footing. So notice that this is buried into the footing before it's cured, and then it is continuing into the foundation wall to prevent any lateral movement. This keyway is doing the same thing. And then these dowels are going all the way along the length of the footing around the perimeter. And there are 18-inch on center spacing between or in between the dowels into the wall and the footing. So we have number 2, number 4 dowels. And the last question, the bracing shown in A5 TS 40.1 affects the location of the doors in what rooms of the building? And we might have to look at the architectural set it's saying here. So we have to maybe go back and open the architectural set through the link that's provided. So let's see what it is, and then we're going to see if we can figure out how to read that bracing like I showed you, and we'll see where it is and why it affects the doors in that room. So let's go first to the TS 40.1. That's what we have to go find first. So TS 40.1. Oop, too far. There we go. And it says, look at A5. There's A5 right there. And we are between columns 7 and 8. And we can see our diagonal bracing that's going on between 7 and 8. So let's look for where that bracing might be. Pay attention to which side 7 and 8 are on, and we'll rotate the plans accordingly. So I'm going to go to line D, column line D, and see if we can find out where that bracing is. So I guess let's go to the first floor, and we'll find it there first. So there's 7 and 8, but remember 7 was on the right-hand side, so I'm going to rotate this view clockwise twice. So it rotates 180 degrees. So it puts column line 7 on the right-hand side and 8 on the left. And then let's look for that bracing. There's that bracing right there. And in this area, there is a door on the architectural plan set, which I will get to this way, I guess. Let's see if we can find it through here. I want to minimize this and go to the set this way. Whoops, it was just there. There we go. So I'm going to go into the architectural set in that same space, which would be in room TA 10.1, or is that the foundation? All right, that still works, I think, because we might be able to see some information on bracing. Whoops. Let's try TA 10.2. Sorry about this. It's not going to show me the information until I sign in, apparently. All right. No, I don't want to start tour. So right here is where we are. We're between column lines 7 and 8. That's where that bracing is, right here. And the location of this door could not be located on this left-hand side because that diagonal bracing is starting at the floor line here and rising up to the second floor column over here on this side. So this door had to fit around this chase and underneath that bracing. And so it had to be placed in just the right place to be able to do that. Unless that's the column line. Was it column line? No, it was column line D. So that door placement, I'm restricted on where I could put that door along that wall based off of which direction that diagonal bracing is going. On the second floor, so if we go to the second floor, it's going to be in the opposite direction. So our diagonal bracing needs to be able to clear that, door again on the second floor. So that's how to read those plans and see what could be affected by a diagonal bracing. If I have diagonal bracing in the wall, it's going to start really low on one end of the wall and go up higher on the other. So it's going to restrict my movement of placing openings and doors and things like that on that bracing wall. I also can't just assume that I can run any kind of piping inside that wall too. So that's important to note where those locations are. So let's write down what that affects. We'll switch to my doc cam here. And actually, I'm not in the ability to do that with this particular video recording. But what I'll put here is this is affects room, it was 218. And 318 door locations. And that is it. So that's kind of your run through and general idea of your structural set. We'll do a similar review of the civil set for you to take a look at next.